Ohayou gozaimasu. Good morning, everyone. This is lecture 14 of Intro to Speech Understanding, fall semester 2025 of KCGI. This is actually the last lecture. We will not have any lectures after this, but I will continue to check here on Canvas to see if you've completed homework, or if you have any questions, you can ask questions on Canvas. The homeworks are all due by the end of February, by no later than February 28th. Please do complete them by the end of February 28th because it's not, I may not be able to extend the deadline beyond that. I may need to submit, I may need to submit grades immediately after that. So please do finish your homework in time. This week, as in previous weeks, the way that we're going to do this is just download the new Git repository. So let me go to on my computer. I think I have this under KCGI Intro to Speech Understanding, and let me do a Git fetch from the release, and then we'll do a Git merge of the release main allow unrelated histories. Ah, must be that there's some local change, so I'll just mark that as local change and then merge it. There we go. Now, if I list it, we see that lecture 14 is there. Let me turn on the transcription because I think I don't yet have a transcription. Now I have the transcription turned on, and so now when I upload this lecture video to YouTube, there will be a transcription beginning at this point in the lecture. Well, let's go ahead and enter lecture 14 then and find out. We'll start at the Jupyter Notebook. As you know, for the first five lectures of the semester, we were really doing a review of Python. The first four lectures were a review of Python. The fifth lecture was NumPy. And then in lectures 6 through 11 were about automatic speech recognition. And in lecture 11, I introduced to you, in lectures 6 through 10, I introduced to you the idea of sampling a waveform in Python and how to compute a spectrogram and how to do automatic recognition from spectrogram features. And then in lecture 11, I introduced you to a toolkit, the Speech Recognizer toolkit, that you can use in order to run many different kinds of commercial speech recognizers on your own inside your own Python application. And then lectures 12 and 13 introduced the basics of speech synthesis. I told you about resonant filters and speech production. I told you about linear predictive coding, which is a way of synthesizing speech or converting your speech so that it sounds like a robot. In today's lecture, I'm going to go back to the idea of introducing you to an API that you can use to include speech synthesis in your own computer program. So the idea will be that we're going to use a available speech synthesizer. GTTS is an open source Python library that basically provides access to Google Translate's text to speech so that you can use Google's speech synthesizer. Google makes their speech synthesizer available on the web for anybody to use for free up to a certain maximum number of trials. And GTTS is just a Python interface. All that it does is it accesses Google's web page and uses Google's speech synthesizer to synthesize speech. But that's a really useful thing to do because that means that you can create your own game or application or whatever you want, and you can give it speech. So the first thing we have to do is to just install it. That can be done using pip install. The funny thing about GTTS is just keeping track of which letters are capital. The package name has the middle two letters capital. The package name that you import has all lowercase, and the synthesizer has the TTS capitalized. It's just kind of funny that way. When you're installing it, you use capital T, capital T. When you're importing it, you use all small case. And when you're synthesizing, you use capital T, capital T, capital S. The way that you synthesize speech is just the simplest that you can possibly imagine. You create a desired text, what it is that you want the speech synthesizer to say. You specify the language using one of the two-letter language codes, and then you synthesize it, and then you save it to an audio file. It's possible to play it back directly, but I find that it's more useful to just save it to an audio file. Then you can use Librosa in order to load from that audio file an IPython to display it. So now it's it's contacting the Google synthesizer, and it's saying, please synthesize for me the text これは合成音声です. And so let's hear how it sounds.
これは合成音声です。
So there are different accents, but not really different voices in this synthesizer. But we can create a different text in any language that you want. For example, we could say, this is speech synthesis, and we could synthesize it in English instead of Japanese.
This is speech synthesis.
There's also British dialect, but we can do funny things, for example, by telling it to synthesize this English text in Japanese, and then it will sound a little bit like a second language accent.
This is speech synthesis.
So you can see that it's produced, this is speech synthesis using Japanese phonemes and Japanese prosody. And so it sounds kind of like a second language production of this English text. I'm not sure if we give it the Japanese text and tell it to produce it as English, I think that it will just give up and be completely unable to do so. But let's find out. That might be interesting.
これは合成音声です。
Oh, so it actually managed to produce it. So this is これは合成音声です produced with an American English accent.
これは合成音声です。
Yes, so we can play fun games with this. Unfortunately, it doesn't come with a wide variety of voices. It really only has this one voice per accent. There are U.S. accents and British accents. Let's look that up. What the heck? We have some time. Let's have a little fun. Localized accents. We can get different regional accents, for example, Australian or UK. Let's try it with an Australian accent. Let me try the English text, but with an Australian accent. That will be TLD equals com.au. Let me try that. I think that's how it works. Let's find out.
This is speech synthesis.
All right. Well, that's supposed to be an Australian accent. At least it's a different voice. If we try United Kingdom, then it should come up with something a little bit different.
This is speech synthesis.
Not very different, but at least it's in a different voice. All right, so you can see that it's very easy to use. You just specify the text and the language and the top level domain of the regional accent in which you want to produce that text. That's about it. That's the main point of today's lecture. In order to make the lecture a little bit more complicated, I'm going to use the speech recognizer to check the output. And the reason that you might want to do that is because using the synthesizer is a great way to produce lots and lots of speech. Right? You can have this one voice produce as much speech as you want. For example, for a video game. If you have a video game and you want the computer to be producing a lot of different speech, then you might want to be able to check to make sure that it worked. And one way to check to make sure that it worked is to actually run the speech recognizer to make sure that the output matches the text. So let me go ahead and produce again the Japanese text.
これは合成音声です。
And now let's try running the speech recognizer in order to recognize that text. And this is complicated very slightly by the fact that GTTS only can write MP3, right? The only audio file format it can write is MP3. And Librosa can read MP3 just fine, but Librosa cannot write an audio file. The speech recognizer can only recognize WAV and FLAC and a couple of other formats, not including MP3. So we need to install a package called SoundFile, which has a wider SoundFile is useful because it has a wide variety of different audio file formats. There are different packages that provide these audio file formats, but SoundFile gives us access, for example, to writing audio in WAV. So we'll use SoundFile write in order to write this speech waveform, and the data is the sample data, and the sample rate is the sampling frequency. And this block is just converting from speech.mp3 into speech.wave. So in fact, if I were to go to if I were, let's see, let me bring up a Finder window. And now if I go to KCGI, uh, here it is, KCGI, Intro Speech Understanding, Lecture 14, you can see I have speech.mp3 and speech.wave now in this directory. Those are just two copies of the same audio, one in MP3 format and one in WAV format.
これは合成音声です。
So the speech.mp3 is 20 kilobytes, and it sounds like that. Speech.wave, on the other hand, is 110 kilobytes and sounds exactly the same.
これは合成音声です。
Right? So they sound exactly the same, but MP3 is much, much smaller file size because MP3 is a more efficient file format. Um, MP3 is partly lossy. It doesn't encode every single sample value of the input audio, but perceptually it sounds quite good. Anyway, now that we've converted it to a .wave, now we can check it using the speech recognition package. So just like in lecture 11, I'm going to import speech recognition. I'm going to create a recognizer, and then I'm going to create a source. In this case, I'll create an audio file called speech.wave. I will have the recognizer be R. Remember, R is the speech recognizer. I'll have that recognizer read in audio from the source and then use, in this case, the Google Speech Recognizer to recognize it. And then I'll say the person in this audio file said, "Kore wa gosei onsei desu." And it says, this does not match the desired text, which was "Kore wa gosei onsei desu." The problem, of course, is that there's a space character. It is exactly the same text, and it didn't match. We asked, is the text the same as the desired text? And the answer was no, because one of them has a space and one of them doesn't. So this is where you need to do some kind of pattern matching. One way that you can do that is to take both the text and the desired text and eliminate any spaces that might occur in either of them. And if we do that, we discover that in fact, the person in this audio file said, "Kore wa gosei onsei desu." This matches the desired text. That's it. That's actually the entire content of this week's lecture. Really, the GTTS is so easy to use. You just type GTTS text language, and it gives you the answer. The speech recognizer we've really already covered. We create a speech recognizer, create a source, create an audio file, and then create the text. So we need a recognizer, a source, an audio file, and a text. So let's look at the homework assignment. Let me go ahead and open up the homework assignment. For this week's homework, we're going to have two functions to write. One will be synthesize. Synthesize will take in a text and a language and a file name, and it will use GTTS to synthesize the speech and then write it to the file name. That's really just one line, right? And we don't return anything at all. So we'll just do GTTS.GTTS, text equals text, language equals language, and then we have to save it to the file name. And I think that's all we need. We need to do the speech synthesis, and then once we've got the speech synthesis, we want to save it to the file name. Let me check to make sure that I've got that right. If I run the doc string, and I run this, and it's synthesized the text and the language and the file name.
This is speech synthesis.
Gave me this is speech synthesis. And now English.mp3 has appeared in this directory. This is the file that we just played.
This is speech synthesis.
All right, so we have this is speech synthesis. Now we're going to use it together with the speech recognizer to create a large corpus. And the function make a corpus is a little bit more complicated just to make it interesting. We'll take a list of texts, so one or two or three or four or five texts. We'll take a list of different languages that those texts are in, and then a list of different file names to which we want to save them. And you can assume that your input texts, languages, and file names will each be lists, and each of those lists will have the same length. So for example, the text might be, hello, my name is, will the real Slim Shady please stand up? And the languages are English, 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 and English, and the file names might be file 1, file 2, file 3, and file 4. We then want to run the speech recognizer in order to recognize the texts. So we'll run the speech recognizer in order to read in those four file names. After converting each of them to a .wav file, we'll read in each of those four file names, recognize the text, and then return it. So let me go to homework 14. So first of all, I'm going to go through, first of all, let me just create a recognizer. R is equal to speech recognition.recognizer. And now I want to create the output. Recognize texts as just a list to begin with. Okay, and now I just want to go through each of the texts and each of the languages and each of the file names. And I can do that using Python's zip tool. I haven't showed you zip before, but it's extremely useful. Let's see if I can bring up a help file for it. Here's the AI summary. Here's Python documentation. No, that's not what I want. It's not a zip file. I want the built-in zip function. So the zip function takes a series of lists, 1, 2, 3, sugar, spice, everything nice, and prints out and basically returns one element from the first list and one element from the second list together as a pair. So the first pair is 1 comma sugar, the second pair is 2 comma spice, the third pair is 3 comma everything nice. And so this is a really convenient way for us to write this function. We can say for text comma lang comma file name in zip texts comma languages comma file names, right? And what this does is it creates a zip of those three lists, the list texts, the list languages, and the list file names. It creates a zip of those and returns the tuple text comma lang comma file name each time. And so for each of those combinations, we just have to do GTTS of text equals text, language equals language, and then save it as file name. And then once we've saved it, then we need to somehow convert it from .mp3 into .wav. In fact, these file names are without the mp3 ending, so maybe I want to add that .mp3 ending here. And then I'll use x comma fs is equal to librosa.load of file name plus .mp3. And then I want to save it again using sound file. And how did I specify rate using sound file? I don't remember. Soundfile.write file name and then data and then sampling rate. Okay, so I want to do file name plus .wav. And then the data is X and the sampling rate is FS. Now that I've got it written, now I want to actually read it into the speech recognizer. So let me see here. I want to do something like with speech recognition.audio file as a source, record from the source and recognize the content. So I want to do with speech recognition audio file, file name plus .wav as the source. I want to record from the source and then recognize the text. And the language that I want to use is actually the language in which it was synthesized. And now finally, I want to append that to recognize texts. Finally, once I've done all that, then I want to return recognized texts. So that got a little bit complicated, I guess, because I needed to create the recognizer, and then I needed to synthesize each and every one of those texts and save it in the corresponding file name, and then read in the file name .mp3 and write out the file name .wave, and then read in again the file name .wave as a speech recognizer source, read it into the speech recognizer, recognize the text, and then append that text to the recognized output. Let's save this and let's see if it works. There's enough moving parts there that it's possible that we have a bug. So let's try running the doc string, and then let's try actually running make a corpus with those texts, languages, and file names. And it's running, and we see hello was recognized as hello, my name is was recognized as my name is, will the real Shady please stand up was recognized as will the real Shady please stand up. It's got capitalized, but otherwise it's the same text. So let's just check to see if the grade.py function will match all of those. 100%. All right, so if you get to this point, then you can open GitHub Desktop and go ahead and check in your homework, and then you'll be done for the semester. Let me show you how that works. Here's GitHub Desktop, and we did homework 14. So we'll commit that and push to origin. And then let's go to GitHub. And change to my student account. Here's my student account, and if I look under lecture 14, I find lots of MP3 files which are not relevant, but I find homework 14, which has everything in it that I need, so I can copy this URL and go to Canvas, homework 14, and check it in. So it says, enter the URL of your copy of homework 14. Go ahead and enter the URL here, and then I will grade them by February 28th and issue grades for the semester. Let me stop recording at this point.